Hai and Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad SHAHMI bin SHAMSUL. Today, I will do an experiment called flow over Broad-Crested Weir. The objective of this experiment are to study the behavior of non-uniform flow and to measure the discharge in rectangular open channel. Let's check it out. The material that I use for this experiment are a PVC rectangular tube with a width of 9.9 cm and two wooden blocks. One is to block the water and one is act as the weir with a rounded top edge. So the height of the weir is 2.9 cm and the length of the weir is 6.4 cm. And I use ruler to measure the depth of water. Firstly, install the broad-crested weir with a rounded top edge upstream in the rectangular open channel.
Second step, I use a tile to produce a mild slope on the rectangular open channel. Third step, open the source where the water come out and let the water flow over the broad-crested weir and increase in depth. Lastly, measure the depth behind of the weir with the range of length of weir over 12 and length of weir over 2. After we have done the experiment, this is the table of the results, which contain the volume, the time, upstream depth, the experimental discharge, the H, which the measurement behind the weir to the surface of water, the theoretical discharge, and the critical depth. The experimental discharge can be obtained by using formula volume over time, while the theoretical discharge can be obtained by using formula 1.705 BH to the power of 3 over 2. In order to get the theoretical discharge formula, we can derive it from the critical depth formula by rearrange the equation for the discharge. The relationship between energy minimum and the critical depth is critical depth equals to 2 over 2 energy minimum. By combining 2 and 3 equation and simplify it, we can get Q equals to 1.705 BH to the power of 3 over 2, which is equal to the theoretical discharge. For the calculation, we need to use all the parameters that we have measured. Firstly, we need to find the H, which is the depth from the behind of weir to the surface of water, by subtract the upstream depth with the height of broad-crested weir. Next, we need to substitute the H and the width of the channel into the discharge formula that we have derived just now, which is equal to 1.705 BH to the power of 3 over 2. Lastly, we need to substitute the discharge and the width of the channel into the critical depth formula.
We observe that theoretical discharge and experimental discharge is not the same. There are some errors that occurs in this experiment. Firstly is the instrumental that we use to measure the parameters, which the ruler only show 3 decimal points and it will give inaccurate data. Second is the water that come out from the source is not constant at all time and it will disrupt the discharge. So it can be concluded that the behavior of non-uniform flow in this experiment is subcritical flow, which the actual depth of water is greater than the critical depth. And also we can obtain the flow rate, the discharge in rectangular open channel using the formula Q equals to 1.705 BH to the power of 3 over 2. Thank you.